Part C. What percent of adult male dogs at Tony's kennel would you expect to have a weight between 50.1 and 59.7 pounds? So the 50.1 pounds is right up there, so I'm just drawing an arrow to show where it is. And the 59.7 is way over here. So we're just going to add together all the pieces that are there. So that's, we know that there's 34% plus 34 plus 13.5 plus 2.35. Sorry for the crappy writing. That comes to 83.85%. Just add them up. All right, part D. What percent of adult male dogs would you expect to have a weight less than 45.3 pounds? So 45.3 pounds was way down here, right at the very end. And we don't actually have a number for that, but we do know that from the mu down is 50%. So this one is going to be 50, and then we're going to take away the 34, and we're going to take away the 13.5, and we're going to take away the 2.35, and that gets us 0.15%. So that's a very small percentage. What percent of adult male dogs at Tony's kennel would you expect to have a weight less than 48 pounds? Let's go up to the graph. So 48 pounds would be around here somewhere. We actually can't do that because it's not on one of the lines. From what we know how to do right now, we can only use where those lines at the standard deviations are. We will learn how to do that later. But right now we can't do. Because the 48 pounds is not on a sigma line, I'm going to call it. Okay. Example 2. Two baseball teams flew to the North American Indigenous Games. The members of each team had carry-on luggage for their sports equipment. The masses of the carry-on luggage were normally distributed, which means we can use our normal distribution curve with the characteristics shown here. So there's the mu and the sigma for the men's team and the women's team. Sketch a graph to show the distribution of the masses of the luggage for each team. Describe the differences in them. All right, so I did some numbers. The mean is 6, and I made the graph so it would fit because I'm not trying to trick you up on the graphing of anything. So the mean is 6 for both, so that's going to go right in the middle. So this is going to be 6. And then 2 ticks gives us 1 more kilogram. And the women's curve has got a smaller standard deviation, so its peak is going to be higher, and I'm just arbitrarily saying that it's going to be here. I don't really know where it's going to be again because I don't have a picture of this in my head what the different curves look like, but what I do know is that the men's peak is going to be lower than the women's peak. So I'm going to do the men's peak in blue or purple, blue. So I'm just arbitrarily going to say that the men's peak is here. And I also know that the men's curve is going to spread out further. You know what? I shouldn't have put, oh no, I do have the, sorry, I'm just thinking out loud or thinking in my head, which is not a good thing to do when I'm recording. Okay, so I know that the men's curve is going to be lower and wider. So let's just draw it. I'm going to have it sort of tail out to between 11 and 12. Can't even count. Sorry, I'm going to fix these. Telling me I should stop for the day. 9, 10, 11. Okay, let's try that again. So the men's team is going to go from 6 and it's going to curve like that. Whoops, it's not supposed to go below the curve. And this one's going to curve like that. You can tell those are symmetrical, right? Okay, and the women's is a little bit higher and it's going to curve down like this. The area under the curves should be the same for both graphs, okay? Not particularly good, but that's the gist of it, okay? What we have, if we're going to describe the differences in the two situations, so the women's curve is higher and narrower. Men's curve is lower and wider. But it's important to note that the area under both curves is equal, okay? And I'm just going to label that this is the women and this is the men's, okay? Next one says the women won the championship. Each member received a medal and a souvenir baseball with a combined mass of 2 kilograms, which they packed in their carry-on luggage. Add a line to the above graph to show the distribution for the trip home. Okay, so for the trip home, what's going to change is that the mean for the women is going to be 2 kilograms higher. It's going to be right here. Whoops, I should do that in red. But it will be the same shape as the other graph. So I'm just going to try and follow my curves like that there. Okay, so maybe I'll highlight that so you can see that that's that one. Okay, so describe how the distribution changed. Peak is at 8 kilograms, but the shape is exactly the same. Okay, because we didn't change the distribution, we just shifted it all up. Okay, and part C, suppose the women had gone shopping and had also added their purchases to their carry-on luggage. What changes would you expect? Well, they've got more stuff in it, so the mean would increase. And the standard deviation would likely increase because they're not all going to buy the same amount of stuff, right? So the curve will widen, widen and flatten. Okay. And we have one more example, but I'm going to do that on a separate video because somebody's in the kitchen making noise. You bet.